Hello everyone, in this video we're going to review apcalculus AB and BC, three big theorems, IVT, EVT and MVT. Alright, IVT stands for Intermediate Value Theorem, MVT stands for Mean Value Theorem, and EVT stands for Extreme Value Theorem. Alright, now for the IVT, if the function f of s is continuous on a closed interval a, b, and k is any number between f of a and f of b, then there exists at least one value c in the closed interval a and b, such that f of c equals k. Right? So let's get the figure. Here's the symbol of the graph f of s, and this function is continuous on the closed interval a and b right here. So you have f of a and f of b right here. Now if a value of k is between f of a and f of b, so suppose k is right here. So you have at least one value of k such that f of c equal k, right? So it could be right here. So I have the first value right here, right? F of c1, right? You have c1 right here. This is c2. So this is f of c2, right? This is c3, right? This is f of c3, right? Suppose k is right here, so you only have two values, right? This guy and this guy, right? Suppose k is right here, right? You only have one value, right? So to restate this formal statement, we're going to say that on a continuous function, you will hit every y value between two given y values at least one, right? Now note on the AB exam, when writing a justification using the IVT, you must state the function is continuous, even if this information is provided in the question, so keep that in mind. Now we're going to move on to the second theorem, that's called MVT. If the function f of x is continuous on the closed interval a and b, and differentiable on the open interval a and b, then there must exist at least one value of c in the open interval a and b, such that f prime of c equals f of b minus f of a over b minus a. Alright, now let's get the figure as follows. Alright, so look at the figure right here. You see that the function is continuous on the closed interval a and b, and differentiable on the open interval a and b, right? There must be at least one value of c. In this situation, we have two values of c, c1 and c2 right here, right? Such that f prime of c is equals f of b minus f of a over b minus a. Remember, the line right here is the secant line, right? So this one is the average rate of change of the function f of s right here, right? And f prime of c actually the slope of the tangent line of the function right here. So if f prime of c equals this one, actually two lines right here parallels, right? Similarly, this guy and this guy parallel, right? So you have two values of c right here. Now we're gonna restate the theorem. If conditions are met, very important, there is at least one point where the slope of the tangent line equals the slope of the secant line, right? So on the IVT exam, when writing a justification using the mean value theorem, you must say the function is differentiable. Remember that continuity is implied by differentiability, even if this information is provided in the question, right? So keep in mind, if the function is continuous, it doesn't mean that the function is differentiable, right? So for example, if you have the function like this and you have the sharp turns right here, the function is not differentiable right here, right? So this statement is not true, right? But if the function is differentiable, and then it's gonna be continuous, so keep that in mind. Question may ask students to justify why the MVT cannot be applied, often using piecewise functions that are not differentiable over an open interval. Right? Now let's move on to the last theorem, EVT. A continuous function f(s) on the closed interval a and b attains both an absolute maximum f of c greater than or equal to f of s for all s in the interval and an absolute minimum f of c less than or equal to f of s for all s in the interval. To restate the theorem, we're going to say every continuous function on a closed interval has a highest y value and a lowest y value. Now let's get the figure. Alright, so the function is continuous on a closed interval a and b, and the highest y value is right here. And this is absolute maximum, right? And the absolute minimum is right here. Now on the AP exam, when writing a justification using the EVT, you must say the function is continuous on the closed interval, even if the information is provided in the question. Now, we're going to go back to the mean value theorem right here. Suppose f of b equals f of a, right? Does that mean f of b subtract f of a equals 0, right? So then f prime of c equals 0, right? So this one is the special case. This is called the Rolle theorems. Right, so the Rolle theorem is the special case of the mean value theorem. Now let's move on to question 1. If f is continuous for s greater than or equal to a less than or equal to b, and differentiable for s greater than a less than b, which of the following could be false? Answer choice A. F prime of c equals f of b minus f of a over b minus a for some c between a and b. This is true by the mean value theorem, right? Now, answer choice B, f prime of c equals 0 for some c such that c between a and b. This is false, right? Because f of a equals f of b is not given, right? Look, f prime of c equals 0 if f of b equals f of a, right? Since this one is not given, making this one false, right? Now, answer choice C. F has a minimum value on the closed interval a and b. This is true by EVT, right? Now answer choice D. F has a maximum value on the closed interval a and b. This is true by EVT, right? Now answer choice D. Interval from a to b of LS dx exists. This is true by definition of intervals, right? So answer must be B. Now let's move on to question 2. The function f is defined on the closed interval 2, 4. If f of 2 equals f of 3 equals f of 4 on the open interval 2 to 4, and the function f is continuous and strictly decreasing. So we're going to sketch the graph to see what happens. So if this one happens, f of 2 could be right here. F of 3 could be right here, and f of 4 could be right here. So this guy right here should be horizontal, right? And the function becomes discontinuous. And then the extreme value theorem does not apply because the function is discontinuous, right? So the function does not have the maximum nor minimum value, right? So the answer must be A. Now question 3. Let f be a function with first derivative defined by this guy for s greater than 0. it's known that f of 1 equals 7, f of 5 equals 11. What value of s in the open interval 1 to 5 satisfy the conclusion of the mean value theorem for f on the closed interval 1 to 5? Alright, so we're going to use the mean value theorem, right? So we have f prime of c equals f of b minus f of a over b minus a, right? Now f prime of c is right here, right? So I just replace s with c, right? So I have 2c squared minus 5 over c squared equals f of b is right here, 11. F of a is 7, right? So 11 minus 7 over 5 minus 1, right? So I'm going to simplify this one. It's going to be 4 over 4, right? It's going to be 1, right? So I'm going to multiply both sides by c squared, right? So I have 2c squared minus 5 equals c squared, right? Subtract c squared both sides, so I have c squared, and then add 5 both sides, so it could be 5, right? Take square root both sides, so it could be c equals plus and minus square root of 5, right? But the domain is 1 to 5, right? So only c equals square root of 5 works, right? So the answer must be D. Now let's move on to question 4. The function f is continuous on a closed interval 0 to 2 and has values that's given in the table above. The equation fs equals 1 over 2 must have at least 2 solutions in the interval 0 to 2 if k equals how much, right? So basically, we're going to apply the IVT, right? Now this is the function f of s, right? So we have the interval 0 to 2, right? We split this one into 2 intervals, right? The first one right here and the second one right here. So we need to find at least one solution in this interval, right? And another solution in this interval, so that we're going to have at least 2 solutions, right? So look at the value of 1/2 right here, right? So by the IVT, 1/2 must be between 1 and k right here, right? So then k in this situation must be less than 1/2 for the first one, right? Now second one, 1/2 right here must be between k and 2 right here, right? So again, k right here must be less than 1/2 for second term, right? So both times k must be less than 1/2, right? We look at the answer choice right here. A must be the correct answer, right? Now for answer choice B, we only have one solution right here, s equals 1, right? Because k equals 1/2. For answer choice C, D, and E, we have no solution because with this value, the function would stay above the line y equals 1/2, right? Now let's move on to question 5. Let g be the continuous function on the closed interval 0, 1, and let g of 0 equals 1, g of 1 equals 0. Which of the following is not necessarily true? Answer choice A. There exists a number h in the closed interval 0, 1, such that g of h greater than or equal to g of s for all s in the closed interval 0, 1. This one true by the extreme value theorem, right? This guy actually absolute maximum, right? Now answer choice B, for all a and b in the closed interval 0, 1. If a equals b, then g of a equals g of b. This is obvious, right? Now answer choice C. There exists a number h in the closed interval 0, 1 such that g of s equals 1/2. Look at 1/2 right here is between the output value right here, 0 and 1, right? So this is true by the IVT, right? Now answer choice D, there exists a number h in the closed interval 0, 1 such that g of s equals 3/2, right? So 3/2 is outside this guy right here, right? So this one is not necessarily true, right? You can consider the function g of s equals 1 minus s on the closed interval 0 and 1, and you will see that it's completely false, right? Now answer choice E, for all s in the open interval 0, 1, limit of the function g of s when s approaches h equals g of s? Yes, this is correct because the function is continuous, right? Now, question 6. If f of s equals sine of s over 2, then there exists a number c in the interval pi over 2 to 3 pi over 2 that satisfies the conclusion of the mean value theorem. Which of the following could be the value of c? Alright, so remember we have the mean value theorem is given by the formula f prime of s equals f of b minus f of a over b minus a, right? Now we're gonna replace s with c, so we have f prime of c equals f of b is right here, a is right here, right? So you have f of 3 pi over 2 minus f of pi over 2 over 3 pi over 2 minus pi over 2, right? Now f of c, which means we're going to take the derivative of this one and we replace s with c, right? So we have f prime of s equals, we're going to use the formula sine u prime. It's going to be u prime cosine u, right? So u is going to be s over 2, right? So it's going to be 1 over 2, right? Cosine s over 2, right? So it turns out to be 1 over 2 cosine c over 2, right? Equals f of 3 pi over 2, substitute 3 pi over 2 over here, right? So we have f of 3 pi over 2 equals sine of 3 pi over 2 divided by 2. It could be 3 pi over 4, right? And it's going to be root 2 over 2, right? So I have root 2 over 2 here. Subtract f of pi over 2 equals sine of pi over 4. It's going to be root 2 over 2, right? So I have root 2 over 2 right here. Over 3 pi over 2, subtract pi over 2, it could be 2 pi over 2 and it could be pi, right? So it could be 0, right? So it's going to be cosine of c over 2 equals 0, right? So c over 2 equals pi over 2 and c equals pi, right? So the answer is D. Now let's move on to question 7. Which of the following theorems may be applied to the graph below? So this one is the graph of the absolute value function. Now, remember you have the sharp turn right here, which means the function is not differentiable at this point, right? So if the function is not differentiable at this point, the mean value theorem does not apply, right? The mean value theorem requires the function to be differentiable, right? So this one is not true, right? Intermediate value theorem could be right. Extreme value could be right. Because these two theorems right here require the function to be continuous only, right? So the answer should be 2 and 3, which is D. Now let's move on to question 8. The function f is defined by f(s) equals 4s squared minus 5s plus 1. The application of the mean value theorem to the function f on the interval 0 to 2 guarantees the existence of the value of c, where c between 0 and 2 such that f prime of c equals, alright, so we have the formula f prime of c equals f of b minus f of a over b minus a, right? Now f of b is going to be right here, f of 2, right? Subtract f of 0 over 2 minus 0, right? Now f of 2 substitute over here, we have 7. F of 0 substitute over here, we have 1 over 2, and it's going to be 3. The answer must be B. Now question 9. A function f is continuous on the closed interval 2 to 5. F of 2 equals 17, f of 5 equals 17. Which of the following additional condition guarantees that there exists number c is in the open interval 2 and 5 such that f prime of c equals 0? This guy actually the Rolle's theorem, right? Remember, the Rolle's theorem is the special case of the mean value theorem, right? So in order to apply the mean value theorem, you need the function to be differentiable, right? Now, the question just gives you continuous, that's not enough, right? So the answer must be C, right? The function must be differentiable. Now let's move on to question 10. The table above gives values of a differentiable function f and its derivatives as selected values of s. If h is the function given by h of s equals f of 2s, which of the following statement must be true? Alright, so before we're gonna do this one, let's calculate the function h of s first, right? So we have s equals 0, 2, 4, and 8 right here, right? So we have h of 0 is actually f of 0, right? Because 2 times 0 equals 0. Now f of 0 equals 3, right? Now h of 2 equals f of 4, right? And it's going to be 9 right here. Now h of 4 equals f of 8, right? It could be 13 right here. We need to take derivative of this guy, right? So we have h prime of s. We're going to use the chain rule, right? So it could be 2 times f prime of 2s, right? So h prime of 0 equals 2 times f prime of 0 times 2, it could be 0, right? So f prime of 0 is 0 right here, so the answer is 0, right? Now h prime of 2 equals 2 times f prime of 4, right? F prime of 4 equals 1 right here, so the answer is 2, right? Now h prime of 4 equals 2 times f prime of 4 times 2, it could be 8, right? So f prime of 8 equals 2 right here, right? So it could be 4. Number 1. The function h is increasing on the interval 2 to 4. Alright, so in order for the function to be increasing on this interval 2 to 4, we need h prime of s should be greater than 0 for all s in this interval, right? Now, since we don't have information about the behavior of the function f prime of s between 4 to 8, right? Right here. Function h from 2 to 4. The function f must be from 4 to 8, right? If we look at the table of values right here, it's likely increasing. But because it's not guaranteed by the data provided, we cannot say it must be true, right? So number 1 could be true, could be false, right? So we need to eliminate this one. Now number 2, there exists the value of c where c between 0 and 4 such that h of c equals 12. This is true by IVT. Why? We look at this guy right here. Alright, there's number c between 0 and 4, so look at the input right here, 0 and 4, right? The output is 12, yes, 12 between 3 and 13, right? There is it number c where c between 0 and 2 such that h prime of c equals 3. So we need to calculate h prime of c. It's gonna be equals h of 2 subtract h of 0, right? The interval right here, over 2 subtract 0 by the mean value theorem, right? Now h of 2 we get 9 right here, h of 0 we get 3 right here, divide by 2, right? 9 subtract 3, it could be 6 divided by 2, it could be 3, exactly this value right here, right? So 2 and 3 correct, right? So the answer must be C. Now let's move on to question 11. The function f is continuous for s between -2 and 1 and differentiable for -2 to 1. If f of -2 equals -5, f of 1 equals 4, which of the following statement could be false? So we see that C between -2 and 1, which is between the input right here, and then the output 0 right here between -5 and 4, right? So this is true by IVT, right? Now B, there exists number C between -2 and 1 such that f prime of C equals 0. This one is the Ross theorem, right? Ross theorem is the special case of the mean value theorem, where f of B equals f of A, right? Now we look at this one, f of 1 and f of -2 right here, they are not the same. Look, -5 and 4, right? So B is wrong. Now C, there exists number C where C between -2 and 1 such that f of C equals 3. This is true by IVT, right? Because C between -2 and 1, right? And then f of C is between -5 and 4, right? So this one true by IVT. Now D, there exists number C between -2 and 1 such that f prime of C equals 3. This is true by the MVT, right? Look, we have f prime of C equals f of B, which means f of 1, subtract f of -2, right? Divide by 1, subtract -2, right? So it's going to be f of 1 equals 4 right here. Subtract f of -2 equals -5, right? So it could be subtract -5 over 3. It's going to be 9 divided by 3. It's going to be 3. Exactly this value right here, right? So this one true. Now E, there exists number C between -2 and 1 such that f of C greater than or equal to f of S for all S on the closed interval -2 to 1. This is obviously true by the EVT, right? Extreme value theorem. So the answer must be B. Now let's move on to question 12. The table above shows selected values of a continuous function g for s between 0 and 11. What is the fewest possible number of times g of s equals 2? Now in order to do this problem, we're going to use the IVT, right? So we look at the first interval right here, right? Now, there exists number C between the interval 0 and 2, such that g of C equals 2, right? 2 is between 1 and 2.8, right? So this is the first. Now, second interval from 2 to 5, right? There is a number C in this interval such that g of C equals 2. 2 is between 2.8 and 1.7, right? So this one is the second value, right? Now the third one is going to be 9 to 11 right here. There is number C in this interval such that g of C equals 2. 2 is between 1 and 3.4, right? So g of S equals 2 at least 3 times, right? The answer must be C. Now let's move on to question 13. Hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at a time t between 0 and 6, given by a differentiable function c, where t is measured in minutes. Select the values of c of t measured in ounce, given in the table above. Is there a time t between 2 and 4 at which c prime of t equals 2? Alright, so we're going to apply the mean value theorem, right? Now, before we're going to apply the mean value theorem, make sure the function is continuous and differentiable on the interval, right? So, look at the information given right here. The function c is differentiable, right? So, if the function differentiable, it implies that the function is continuous on the closed interval, right? Now we're going to check within this interval, right? So we have c of 4 subtract c of 2 over 4 minus 2, right? So C of 4 is right here, 12.8. And C of 2 is right here, 8.8 divided by 4 minus 2. And it could be 4 divided by 2, it could be 2. This value is exactly this value, right? So we're going to say yes by the mean value theorem. There is at least a number t between 2 and 4 for which c prime of t equals 2, right? Now let's move on to question 14. Train A runs back and forth on an express section of railroad track. Train A's velocity is measured in meters per minute given by a differentiable function v sub a of t, where time t is measured in minutes. Select the values for v sub a of t given in the table above. Do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t between 5 and 8. Alright, so we're going to apply the IVT. So in order to apply the IVT, the function must be continuous, right? So since the function is differentiable right here, it implies the function is continuous, right? Now we look for the interval 5 to 8, right? So 5 right here and 8 right here, right? So there is number t between 5 to 8 such that negative 100 right here between negative 120 and 40, right? Now let's move on to question 15. A continuous function f is defined on the closed interval negative 4 to 6. The graph of f consists of a line segment and a curve that is tangent to the x-axis at x equals 3, right here, as shown in the figure above. On the interval 0 to 6, the function f is tridifferentiable with f double prime of s greater than 0. Question C. Is there a value of a such that a between negative 4 and 6 for which the mean value theorem applied to the interval a to 6 guarantees a value c for c between a to 6 at which f prime of c equals 1 over 3. Now we're going to apply the mean value theorem, right? So we have f prime of c right here equals 1 over 3, right? And this guy actually f of b minus f of a over b minus a, right? Now a equals a and b equals 6, right? So we have f of 6 minus f of a over 6 minus a, right? So f of 6 is going to be 1 right here. F of a, we don't know it, we just leave it right here, right? Over 6 minus a, right? Now we need this guy right here to be 1/3, right? So we can check the value within this interval right here, right? So I'm going to check a equals 3 first, right? So I substitute over here, I have 1 minus f of 3 equals 0 right here, right? Subtract 0 over 6 minus 3, and it's going to be 1/3. So this one is exactly this one, right? So we can conclude that a equals 3, right? Now let's move on to question 16. Let g be a continuous function with g of 2 equals 5. The graph of the piecewise linear function g prime, the derivative of g is shown in the figure above for s between negative 3 to 7. Question D. Find the average rate of change of the function g prime of s on the interval negative 3 to 7. Does the mean value theorem apply on the interval negative 3 to 7? Guarantee a value of c for c between negative 3 to 7 such that g double prime of c is equal to the average rate of change. Why or why not? Now we need to find the average rate of change of the function g prime of s on the interval negative 3 to 7, right? So we have g prime of 7 subtract g prime of negative 3 over 7 subtract negative 3, right? So g prime of 7 is going to be 1 right here. Subtract g prime of negative 3 is going to be negative 4 right here. Over 10, and it's going to be 1/2, right? Now, does the mean value theorem apply on this interval? guarantee value of c for c between -3 to 7 such that g the program of c is equal to this average rate of change? We're going to say no, right? Because in order to apply the mean value theorem, the function must be differentiable on that interval, right? But look at this one right here. We see that the function has a sharp turn right here, sharp turns right here, sharp turn right here. So the function is not differentiable on those values, right? So we need to say the mean value theorem does not guarantee the existing value of a value of c with the stated properties because g prime is not differentiable for at least one point on this interval, right? Now let's move on to question 17. The function f and g is differentiable for all real numbers and g is strictly increasing. The table above gives values of the functions and their first derivative as selected values s. The function h is given by h of s equal f of g of s minus c. Question A. Explain why there must be a value r for r between 1 and 3 such that h of r equals -5. Alright. So first we need to calculate h of 1, right, equals f of g of 1 minus 6, right? So it can be f of g of 1 is 2 right here, right? So f of 2 minus 6, f of 2 is 9 right here. 9 minus 6 equals 3, right? Now h of 3 is going to be f of g of 3 minus 6. So g of 3 is going to be 4 right here. So f of 4 minus 6. f of 4 is going to be -1. -1 minus 6 could be -7, right? So, in order to answer this question, we need to use the IVT, right? So we look at the output right here, -5 right here is between -7 and 3, right? And the input right here is between 1 and 3 right here, right? Which is this guy, right? So, we're going to say that since the function f and g are differentiable, right? It implies that the function f and g are continuous, right? Then the function h is continuous, right? So by the IVT, there exists a number r between 1 and 3 such that h of r equals -5, right? Now let's move on to question B. Explain why there must be a value of c for c between 1 to 3 such that h prime of c equals -5. Alright, so we're going to use the MVT, right? We need to calculate h of 3 minus h of 1 over 3 minus 1, right? So h of 3 equals -7 right here. Minus h of 1 equals 3 right here. Over 3 minus 1 equals 2. So it could be -10 over 2 equals -5, which is equals h prime of c, right? So we need to say that since the function h is continuous and differentiable, the mean value theorem applies, right? So by the mean value theorem, there exists a value of c between 1 and 3 such that h prime of c equals -5, right? Let's move on to question 18. Let f be a tridifferentiable function such that f of 2 equals 5, f of 5 equals 2. Let g be the function given by g of s equals f of s. Question A. Explain why there must be a value of c for c between 2 to 5 such that f prime of c equals -1. Alright, so this one implies the mean value theorem, right? So we need to calculate f prime of c is going to be f of 5 minus f of 2 over 5 minus 2, right here. F of 5 equals 2 right here. f of 2 equals 5 minus 5 over 3, right? So it could be negative 1, which is equal to this one right here, right? So you need to say that since the function f is continuous and differentiable, the mean value theorem applies, right? So by the mean value theorems, there exists a number c between 2 and 5 such that f prime of c equals negative 1, right? Now question B. Show that g prime of 2 equals g prime of 5. Use this result to explain why there must be a value of k for k between 2 and 5 such that g double prime of k equals 0, right? This one implies the Rolle's theorem, right? Alright, so we need to find g prime of s first, right? Take the derivative of this one using the chain rule, right? So it could be f prime of s times f prime of f of s, right? Now we need to calculate g prime of 2 and g prime of 5 to see what happens, right? So we have g prime of 2 equals f prime of 2 times f prime of f of 2, right? So it could be f prime of 2 times f of 2 equals 5 right here, right? So it could be times f prime of 5. Now g prime of 5 equals f prime of 5 times f prime of f of 5, right? F of 5 right here equal 2, right? So we have f prime of 2 times f prime of 5, right? So we can conclude that g prime of 2 equals g prime of 5, right? Now to answer this question right here using the Rolle's theorem, we need to say that the function f is twice differentiable, then the function g prime is differentiable everywhere. So the mean value theorem applies. So by the mean value theorem, there exists a number k between 2 and 5 such that g double prime of k equals g prime of 5 subtract g prime of 2 over 5 minus 2, and this guy actually 0 because this guy and this guy the same, right? Now let's move on to question D. Let h of s equals ls minus s. Explain why there must be a value of r between 2 and 5 such that h of r equals 0. Alright, so we're going to use the IVT, right? So we need to calculate h of 2. It's going to be f of 2 minus 2, right? F of 2, we're going to use the value right here. It's going to be 5, right? So it will be 5 minus 2 equals 3. Now h of 5 equals f of 5 minus 5, right? F of 5 equals 2, right here, right? So it will be 2 minus 5 equals negative 3, right? Now look at this one right here, h of r equals 0, right? 0 is the output. This one falls into the interval negative 3 to 3, right? And r right here is the input, fall into this interval 2 to 5, right? So the IVT applies because the function h of s is continuous, right? So we need to say that since the function h of s is continuous and h of r equals 0 is greater than negative 3 less than 3, then by the IVT there must be a number r between 2 and 5 such that h of r equals 0. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher.